All right, so share screen. I don't know if Caitlin watched yesterday. We did two things. We did dilutions, which are you're given three numbers. Wow, that was loud.
Yeah, I've watched the last three videos.
Oh, okay. So dilutions are relatively straightforward, I hope. You're given a volume of a concentration and another thing, and then we have to dilute. Um, it's just using a formula. So we did that, and we looked at starting solution stoichiometry, which is not as clean and pretty as gravimetric stoichiometry because you have to actually do things stepwise, and I mean, we can get all sorts of combinations in here. Fundamentally, it's the exact same idea. Calculate a moles, convert moles, calculate a quantity. Um, Gravimetric, we can do it all nice in one line. Solution, we have to do everything. We have an equation. Find the number of moles of what we're given. In that case, it was nitric acid. Da, 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 da. Find the unknown number of moles by, that's the stoichiometry step. Where's my cursor? Come on. And then in this case, it was find another concentration um, or a volume. More often than not, you're looking for a concentration, but that's okay. You do this idea a lot in acid-base chemistry in chemistry 12. So I'm going to do that example. These three are ones that are a little bit different, so I may do one or two of those, but it's the same thing because I don't know if I put all of those in there. And then there's, I think, a couple other questions to practice, and I'll make sure those are in there. And that's kind of the end of chapter 16. I posted the assignment that is 12, 15, and 16. Um, Technically, as long as you have it submitted by the 12th, it'll be fine. Um, so, a 10 milliliter sample of sulfuric acid reacts completely with blah 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 potassium hydroxide. Calculate the concentration of sulfuric acid. So that this type of question is one that on an exam, the last question would potentially be a stoichiometry question where you have to write an equation, where you have to balance an equation, where you have to do everything together because that's ultimately what the real goal is, to be able to do to put all of the pieces together. So sulfuric acid and potassium hydroxide is a double replacement reaction. You get potassium sulfate, two waters, and you would need two of those. So we're given a 10 milliliter sample. So I'm going to convert that to liters. We want to know concentration. We're given a volume of 0.0159 liters. We're given a concentration. So this is the one we start with. 1 N of KOH equals C times V equals our concentration, 0.15 molar, and our volume. We can do that calculation once I find my calculator. So we have 0.002385. And personally, I'm going to use, like that terminates, it's a terminating decimal. I'm going to use that for significant figures because fundamentally significant figures, I want to keep some stuff and round at the end. So first step is moles of potassium hydroxide. Whoops, I'm trying to say two things at once. convert potassium hydroxide moles to sulfuric acid. This is the stoichiometry, 0.00238 moles of potassium hydroxide. I want to get rid of potassium hydroxide. I want to convert it to moles of sulfuric acid. We go to our balanced equation. 1 mole of this uses 2 moles of that. That's going to give us moles of sulfuric acid. So this is where the numbers in the calculator. A lot of high school students love to clear numbers out of their calculator. If you're going to use it again, don't push clear in times. Well, 1 divided by 2, or just divide by 2. I was going to multiply by 0.5, 0.001911925 moles of sulfuric acid. Calculate the concentration of H2SO4 because that's what this step is, what are you asked in the question. So now we have, if I went up here, I have moles, I have volume, I can find concentration, whoops, sorry. Concentration of sulfuric acid equals moles divided by volume. Moles divided by, technically it's 3 or 4, 3, 3, so we're going to want 3 significant figures at the end. 0.01000. So that's going to move the decimal place over 2. So the final concentration of sulfuric acid after I do moles divided by volume is 0.119. So our concentration is going to be different. We had a totally different volume. The magnitude, sometimes you're going to have these concentrations depending on the stoichiometry where they're vastly different. But if you follow those 3 fundamental steps, moles, convert, and your unknown, it's going to be the same thing. If we went back to chapter 12 when we did gravimetric stoichiometry, that very first example was calculate the moles of the first thing based on mass. Convert, and then calculate the mass from the moles. It's the same even though we're doing this sort of thing. So, these are 3 that I would normally give you. They're, I think, in there. I think I initially did 1 to 11 in the file. Let's see which one's kind of the most interesting. Oh, let's look at number 3 because it's got sodium carbonate reacting with iron 3 chloride. What is the minimum volume of that needed? We have a bizarre equation. So I'm going to just sodium carbonate reacts with iron 3 chloride. Just because I don't want to. Sodium carbonate. Iron 3 chloride. It's a double replacement reaction. Plus, so this is NaCl. Iron 3 carbonate is going to be, whoops, that almost looked like a C. So there's our skeleton equation. 2, that's a 3, sorry. That's 2 iron. I need 2 iron. 3 carbonate, 3 carbonate. 3 times 2 is 6 sodium, 2 times 3 is 6. So there's our equation. Sodium carbonate is 0.250 molar. We don't. Volume of sodium carbonate. Concentration of 75 mils is 0.750 liters. Moles of iron carbonate is concentration times volume. Liters. So I can do that. So 0.015 moles of iron carbonate, or iron chloride, sorry, convert to sorry. So we do our conversion 0.0150. Oh no. I don't want moles of that. I want moles. Why am I writing iron twice? There's a 2 there. There's a 3 there. So we have a slightly different ratio, but times 3 divided by 2 is 0.0225 sodium carbonate. Picked up. No, Emma must still be asleep. So we have that. Our third step is this one is find. So C equals N over V. B gets N equals C times V. So our formula is volume equals moles over concentration. We have the number of moles. We have the concentration. Hmm. 0.0225 moles divided by 0. Moles divided by moles per liter. So if you just look at units, well, dividing by a fraction, we multiply by the reciprocal. The reciprocal of moles per liter is liters per mole. And this is why we end up with a volume at the end. 0.0225 divided by 0.250 is 0.0900 liters or 90 milliliters. So it's other than the fact that the equations are slightly different, it's just a variation on a theme. I'll put those questions in. 9 is a dilution, 10 is dilution, and that last one that doesn't really have a number is a stoichiometry question. Where am I going? What's going on? Huh? Okay. But that's really it for that. That would give you kind of everything we you would need for that assignment. Um, on Thursday and Friday, and well, Friday I have to go to school for the first time, so we have a meeting at 8:45. I have no idea how long it's going to last or what's going to happen. Oh right, I canceled this class. It's math that I haven't canceled yet. I'm probably going to just do that and give everybody a Friday off. We have to talk about empirical formula and a couple of things from that's the moles chapter. I'd like to mention gas laws a little bit. There won't be anything assigned on it, um, but the gas laws are something that are a little bit important. Um, so that's kind of my thought for next week. There won't be any evaluation on that. Um, I think I put the next assignment, the last assignment due on Wednesday. I may say if you have questions, you can come and ask them next week, but we'll look at the gas laws quickly. The gas laws might take a couple days. Empirical formula and stuff might take a couple of days. Um, but that's kind of the plan for that. Does that sound okay?
Sounds good to me.
All right. That's all I've got for this morning. I'll make sure all those right things are in the right spot. Um, and we'll see you guys on Thursday.
Okay, sounds good.
Okay.
Bye.
Bye.